Summer of 1935, in the quiet academic air of Princeton, New Jersey, two minds were preparing to change the way humanity looked at the universe. Within the walls of the Institute for Advanced Study, Albert Einstein and Nathan Rosen worked together on an idea that would stretch the imagination as far as the stars themselves. They discovered that Einstein's own equations allowed for hidden corridors through the fabric of space and time, gateways that could, in theory, join two distant regions of the cosmos. These bridges, later called Einstein-Rosen bridges, or simply wormholes, offered a vision of the universe folded upon itself, where the most distant stars could be reached not through endless travel, but by stepping through a cosmic shortcut. To understand the scale of this revelation, one must recall that the nearest star system to Earth lies more than 4 light years away. Light itself, traveling at 186,000 miles every second, would need over 4 years to bridge that gap. For any being to attempt such a journey, only a passage beyond ordinary space would suffice. But creating such a gateway demands energy on a scale far beyond the reach of humankind. Physicists estimate that it would require transforming the entire mass of Jupiter into pure energy, a magnitude millions of times greater than that released by a nuclear explosion. Some theorists propose that the key might lie in a substance yet unseen, exotic matter, material with negative mass capable of holding a wormhole open against the pull of gravity. Others suggest that these tunnels may have formed naturally in the chaos of the Big Bang, when the newborn universe twisted and folded in on itself. In that first instant of creation, when matter and energy collided in blinding fury, the very fabric of space-time may have been punctured, leaving behind infinitesimal pathways through the void. Over billions of years, as the universe expanded and stretched, those tiny bridges might have grown into vast, unseen corridors connecting the stars, silent relics of the universe's own birth. November of 2022, Santa Barbara, California. Inside a laboratory, humming with the pulse of quantum processors, a research group led by Caltech physicist Maria Spiropoulou achieved something once confined to theory. Working with Google's Sycamore quantum computer, her team constructed a digital model of the universe and produced a measurable simulation of a traversable wormhole. Within this microscopic cosmos, information moved from one processor to another, as if slipping through a bridge in space-time. A symbolic but genuine step toward exploring how such gateways might function. Though no physical tunnel opened in the air, the experiment demonstrated that the mathematics behind Einstein's relativity could, in principle, be reproduced and observed inside a quantum system. It was a moment when computation met cosmology. Modern physics now imagines space and time as a flexible fabric that can curve, twist, and perhaps connect distant regions of reality. Decades earlier, Stephen Hawking had argued that constructing an artificial passage between points in the universe would be extraordinarily difficult, but not impossible within the laws of nature. The work of today's quantum scientists brings that speculation closer to testable ground. Across centuries, myths of celestial doorways and starlit passages have haunted human imagination. What was once described as divine travel through sacred gates is now being translated into equations and experimental design. The idea of a stargate has left the realm of legend and entered the vocabulary of physics, not as fantasy, but as a concept to investigate. If one day humanity learns to stabilize such a bridge, the consequences would be transformative. Distances that once defined isolation, the span from Earth to the Moon, to Mars, or beyond, could collapse into moments. Journeys across the solar system might require only the precision of quantum coordinates, rather than years of propulsion. The potential reaches far beyond travel. A working wormhole would offer insight into the hidden geometry of the universe, the nature of gravity, and the unseen dimensions that shape reality itself. Should that frontier ever be crossed, it would mark not merely a technological triumph, but the opening of a new epoch, an age in which humanity stands at the threshold of the stars, ready to explore the infinite corridors of its own creation. Cal State Fullerton, 2013. In a small, softly lit laboratory tucked inside a public university in Southern California, physicist Jim Woodward worked quietly on a series of experiments that he believed might one day transform the future of space exploration. The room was unremarkable. Wires railed around tables, digital oscilloscopes blinked in steady rhythm. But within its walls, Woodward was attempting to solve one of the oldest problems in human ambition: how to move through space faster than anything before. His fascination began not with fantasy, but with propulsion, the science of motion. To travel at a meaningful fraction of light speed, conventional engines would never suffice. Rockets depend on expelling mass, throwing fuel out the back to move forward. That very principle limits how far and how fast humanity can go. To break free of that constraint, he reasoned, one must learn to manipulate inertia itself, the invisible property that resists acceleration and ties every object to the rest of the universe. Woodward's research drew its foundation from an idea first proposed in the late 19th century by Austrian physicist Ernst Mach. Known as Mach's principle, it suggested that the inertia of any object is not an isolated trait, but the result of the gravitational influence of all matter across the cosmos. In simple terms, when one pushes an object and feels it push back, that resistance originates from the combined mass of distant galaxies acting through the fabric of space-time. To Woodward, this principle carried revolutionary implications. If inertia truly depends on the mass of the universe, perhaps it could be altered, redirected, or even neutralized. Such control, he believed, might unlock entirely new methods of travel, perhaps even the means to bend space itself. Driven by that conviction, Woodward began constructing a device designed to test Mach's principle in action, using stacks of lead zirconium titanate crystals, known as PZT materials. He built what he called the Mach Effect Thruster. When subjected to alternating electrical currents, these crystals deform slightly, expanding and contracting at high frequency. According to his calculations, this oscillation could cause the effective mass of the device to fluctuate ever so faintly. If the theory were correct, the interaction between that fluctuating mass and the gravitational field of the distant universe would produce a measurable thrust, no propellant required. It would represent a new kind of motion, propulsion through the geometry of space-time itself. To detect such an effect, Woodward mounted his experimental thruster inside a vacuum chamber, isolating it from air currents and vibration. The entire assembly rested on an ultra-sensitive thrust balance, capable of detecting forces smaller than a millionth of a Newton. Over the course of long, meticulous testing, the team recorded the data on oscilloscopes. The blue trace represented power input. The red line captured the thrust output. Each time the electrical frequency shifted, a sudden spike appeared on the graph. A surge of force when the current turned on, and another when it stopped. To Woodward, these traces were the faint but undeniable fingerprints of the Mach effect. The device appeared to move, however slightly, in response to the distant mass of the universe. What began as an attempt to revolutionize propulsion soon evolved into something deeper. The equations hinted at possibilities beyond engines, toward the very bending of space itself. If mass could be shielded, even temporarily, from the gravitational influence of the cosmos, it might expose regions of negative energy. Such energy, according to theoretical physics, could hold open a wormhole and make it traversable. In this way, Woodward's work pointed toward a distant but profound goal: the engineering of gateways through space-time, artificial stargates that could connect distant points in the universe. Though Mach's principle remains a subject of debate among physicists, the persistence of Woodward's experiments has drawn growing attention. Each run of data, each delicate trace on the monitor, brings him closer to demonstrating that inertia and gravity may not be constants, but dynamic properties that can be influenced. He believes that, with sufficient resources and refinement, primitive prototypes of these space-time devices could be built within a few decades. The technology, he insists, would begin modestly. Small test beds of vibrating metal and crystal, but its implications reach as far as imagination allows. If his vision holds true, propulsion would no longer depend on fear or fuel. Instead, humanity could ride the invisible waves of the universe itself, surfing along the gravitational field that connects every atom to every galaxy. The same principle that governs how an apple falls or a planet orbits could one day guide spacecraft across light years. For Woodward, the dream is not only about engines, it is about the unity of all matter, the recognition that every movement here on Earth is subtly shaped by the stars above. In his view, to harness that connection is to take the first real step toward the stars. Should the day come when his thrusters evolve into true gateways, the boundary between science and exploration will fade, and the story of humankind will expand into the infinite sea of space that has always called to us. Gamla Uppsala, Sweden. About 40 miles north of Stockholm, the landscape rises in low, grass-covered mounds beside a medieval church. Beneath this quiet ground lies one of the most important archaeological sites in Scandinavia, a place believed to be the ancient spiritual heart of the Viking world. Excavations beneath the church have revealed traces of a great temple once known as Uppsala, described in a 14th century chronicle called The Deeds of the Bishops of the Hamburg Church. According to the text, it was a magnificent sanctuary dedicated to the three mightiest gods of the Norse pantheon, Odin, Thor, and Freyr, the god of fertility and prosperity, stood at the center of rituals devoted to peace, the bounty of harvests, and the renewal of life. His followers believed he governed the weather, ensuring fertile fields and calm seas, and that his wisdom could ease the constant rivalries among gods and giants. In contrast, the trickster Loki brought chaos to that divine order. Though counted among the gods, he was in truth a giant, a being of another lineage, whose cunning set in motion nearly every conflict told in Norse myth. Without Loki's mischief, the stories of Asgard would lose their tension, for it was his transgressions that forced the gods to act, suffer, and triumph. Among Loki's attempts to make amends for his deceptions was the creation of a gift for Freyr, a vessel called Skidbladnir. The old Eddas describe it as the finest ship ever built, able to travel with unerring speed and a perfect wind, no matter the direction. When its voyage ended, Freyr could fold the entire ship into a pouch small enough to carry at his side. To Viking storytellers, Skidbladnir embodied the ultimate dream of craftsmanship, a vessel of infinite reach and impossible convenience. Yet some have wondered whether Skidbladnir might represent more than poetic imagination. Could it be that early Scandinavians were describing something they had actually witnessed, an advanced craft mistaken for divine technology? Ancient astronaut theorists believe so, pointing to tales of the Sons of Ivaldi, a mysterious race of beings credited with forging the gods' greatest tools. In the myths, these craftsmen, called dwarves, created Thor's hammer, Odin's spear, and other legendary weapons. They were said to dwell beneath the earth, masters of metal and fire, small in stature but unmatched in skill. To modern interpreters of the ancient astronaut hypothesis, the Sons of Ivaldi might not have been mythical dwarves at all. Some suggest they were a race of non-human visitors whose advanced abilities inspired tales of supernatural artisans. Because the Norse people lacked words for such beings, they may have called them little people, likening them to dwarfs. The comparison has drawn attention to a curious parallel. In contemporary accounts of extraterrestrial encounters, the so-called gray aliens are often depicted as small, thin, and pale, features not unlike those attributed to the subterranean smiths of Norse legend. If the Sons of Ivaldi were indeed something other than human, they may have been responsible for crafting devices that appeared miraculous to early eyes, tools of the gods that shimmered, flew, or emitted light. From that perspective, Skidbladnir might be reinterpreted as a vehicle of extraordinary technology, able to expand and contract, to move across great distances, and to be folded away when not in use. But if the Norse gods truly came from elsewhere, how did they reach our world? The mythology offers a clue in the form of Bifrost, the rainbow bridge said to connect Asgard, the realm of the gods, with Midgard, the world of humans. Described as a burning arch of color that the gods used to descend to Earth, Bifrost served as both pathway and barrier, a radiant channel between dimensions. Ancient poets wrote that its red band burned hot beneath divine feet, a perilous yet sacred road to the heavens. Scholars have long debated whether the image of Bifrost was inspired by the Milky Way, the luminous river of stars that stretches across the northern sky. To Viking observers, it may have resembled a glowing causeway, linking their world to another, beyond mortal reach. In modern interpretations, some theorists see Bifrost not merely as metaphor, but as a possible description of an interstellar conduit, a wormhole bridging distant points of space, a cosmic gateway through which celestial beings might travel. Viewed this way, the old Norse myths read like memories of contact, gods arriving through radiant portals, messengers of light moving between worlds, and human witnesses left to translate what they saw into the language of legend. Beneath the soil of Gamla Uppsala, where the temple once stood, archaeologists find traces of devotion and ritual, offering pits, wooden posts, and fragments of gold. Above them rises the quiet church, a symbol of later faiths built upon the sacred ground of the old. Yet within these layers of history lingers a deeper mystery, one that joins myth, astronomy, and imagination. Whether the stories of Freyr's folding ship and the rainbow bridge of the gods preserve echoes of something real, an ancient memory of beings who once crossed the heavens to walk among humankind. And so the story of Gamla Uppsala lingers, part ruin, part legend, part echo of something larger than time itself. The winds that cross the burial mounds still carry whispers of the gods, or of those who once played their roles. Each sunset over the plains paints the sky in the same colors the Vikings saw when they spoke of the Rainbow Bridge, when the Milky Way shimmered like a divine road through the night. In the stillness of the church above the ancient ground, myth and memory seem to fold together. Stone beneath wood, faith upon faith, the old world beneath the new. Somewhere between history and the stars, the bridge remains, whether of light or faith, or something we have yet to name.